Welcome. My name is Keith Vertinen, and this is an online course in the fundamentals of computer science. So in this course, we're going to learn a little bit about the discipline of computer science, what sort of problems computer scientists work on, some of the approaches we use to solve problems. You'll learn important skills in how to program. So in particular, we'll be learning to program in Java. And by learning to program, you'll be able to address all kinds of different problems you might encounter in the business world, in different scientific disciplines, or in engineering. Um, and so, why don't we get started? Here's the book. So I'm using Introduction to Programming in Java. All right, it's a book by two guys at Princeton, Robert Sedgwick and Kevin Wayne. So it's something they've been working on for a number of years, and I think it's the book's a really good introductory book, and it shows you how computer science and how programming can be used to solve important and interesting problems in different scientific and engineering disciplines. So I do recommend you pick yourself up a copy of the book, and each of the video lectures, or at least most of the video lectures, are keyed to certain sections in the book. So I recommend either before or after watching the video lecture, you go through the book and carefully read those sections. The course website also is going to include recommended exercises in the book, and so to help reinforce your knowledge and make sure you're following all the material, I do suggest you work through some of those exercises. All right. In addition to the physical print book, the Princeton guys also have a online book site, and so the book site has additional exercises, some additional information about the different sections and background, and interesting tidbits about the different sections. So the URL is at the bottom of the page here, so you might want to go check out the book site as well as the textbook. All right. One of the main things we'll be doing in this course is learning to program, and maybe you're thinking to yourself, well, why do I need to program this? All right, if you go on the iPhone App Store, there are over 500,000 different software applications. All right, and if you need to know how to tie a knot, there is an app for that. If you need to know how to identify a paw print in the snow, there is an app for that. Okay, cooking your perfect steak on your grill, also an app for that. All right, stretching, yoga, app for that. All right, there are lots and lots of, and this is just iPhone specific apps. All right, you've got the Android App Store, you've got all the software you can download from Windows. There has been a lot of software developed in the world. And so you may think to yourself, why do I need to learn to program myself? All right, well, here are 4 different reasons I'd argue you might want to learn to program. First of all, well, those programs on the iPhone App Store, they didn't just, appear from the ether. Somebody had to go and program all those, and those people are, getting paid when anybody buys those apps. And so you can make a good living as a computer scientist building software, building these programs that are sold on the App Store, or programs that are used by companies and so on. And the second reason, while there's loads and loads of existing software out there, all right, your company or your scientific problem may be so specific, nobody's invented an app for that. All right, you need specific software to address the problem you're facing, and the only way to get a good solution that really fits your needs is to develop it yourself. Okay. Third reason is, well, it's fun. So I've been programming for over 20 years, and I still enjoy doing it. It's a challenging, creative endeavor. All right, building complex software is like creating anything out of nothing. It's satisfying to take all the pieces, put them together, and create something that's beautiful and works. All right, and the final reason is it's also satisfying that you can make your computer do do your bidding. All right. Instead of being a slave to the existing software, maybe Microsoft Excel only does, part of what you need, and you end up doing a lot of tedious operations. You're copying stuff around. You're sitting in front of your spreadsheet for hours doing the same repetitive thing. Okay. Once you know how to program, you don't have to do that anymore. Okay. You can make a program. You could program an Excel macro. All of a sudden, you can get out of the tedious business. You can do a fun, creative engineering process to build the program, and then sit back, have a cup of coffee, and wait for your computer to do its job. All right. So, having decided that maybe we should learn to program, we've got to make a decision. I mean, there are different classes of ways you can get computers to do things. All right, they speak some sort of language, and at a base level, the lowest level, they speak machine language. All right, all your computers have some sort of CPU in them, and the CPU understands this machine language. All right, it's actually what causes those circuits inside the computer to fire and do their job, add numbers together, and so on. The problem with this, I mean, this is the base language, and all computers speak, some variant of a machine language. It's tedious and error prone to write for humans. All right, it's a language that's really designed for the computer hardware to understand. I mean, people can write in it, but it's difficult to do, and what's worse is it's specific to the type of computer. If I learn to write some machine language for my iPhone, it's not the same kind of machine language that's going to run on my Windows PC or even on my MacBook. All right, they're all different types of machine language. All right. Well, ideally, I've got some problem and I can state in natural language, say English, what I want the computer to do. Computer, please add these columns up and, find the other column that has the same sum or something like that. All right. But the problem with natural language like English is it's not so precise. All right. You can easily get some ambiguities in that natural language, and those ambiguous things are going to make it difficult for the computer to actually get the job done, or it's going to do it, but it's going to do it incorrectly. What's worse is actually it's a really hard problem. Converting that natural language to the actual machine language spoken by the processor of the computer, that's a hard thing to do. And so programming a computer natural language isn't something that's really so feasible. The approach we're going to use and how computer scientists generally program is in a high level programming language. All right, it's above the level of this machine language that the CPUs speak, but it's below natural language. So it's a much more constrained language. It has much tighter rules of grammar. It's a lot more pedantic. You have to do things in a certain way to make it work. But it's a nice balance between the two extremes. It's precise and unambiguous, but it's easy for humans to understand. So your first step to becoming a programmer is to choose a language. All right, and here are just some textbook covers for various popular languages. Head first Java, so the Java programming language, Python, C#, C++, JavaScript, COBOL, Lisp, F#. There are hundreds and hundreds of different programming languages. And so which one should you learn to program in? What should be your first programming language? Well, I'll make this easy for you. We're going to use Java. Okay. And it has certain advantages. All right, it's widely used. Okay, it's also freely available. You don't have to pay to download Java from Oracle. All right, and Java has some nice features for novices. It has features that make it easy for novices to learn and don't distract novices with a lot of low-level details. Okay, and so those are some of the advantages, and there's the inventor of Java up there in the upper right. There's really no perfect language. Every language has pros and cons. And in your career as a programmer, especially if you go on in computer science, you're going to learn many different languages. You'll probably learn C and C++. You may learn some assembly, other languages like Python, C#, and PHP, and so on. All right. By and large, a lot of these languages are quite similar. So the skills you learn in Java are going to translate quite easily to these other languages. So it's not like you're wasting your time learning to program in Java. Once you know how to program in Java, you can pick up C++ quite easily. All right. And by time, certainly in the school I teach at, by time we get our computer scientists to their last year, you can introduce a new language and the students will pick it up, just within a week. And there's a quote by the father of C++. There are only two kinds of languages: the ones people complain about and the ones nobody uses. So his point is there is no perfect language. You can always criticize any language, but Java is, I think, a good choice and the language we're going to use in this course. All right. Having decided we want to program and having decided that Java is the language we want to use, tradition dictates that we learn to program by making a Hello World program. And the whole goal of Hello World is just to print out Hello World. But what you learn by doing Hello World is some of the infrastructure, like what kind of steps do I have to go through in order to get the computer to print out this simple message. All right, and here's that first program printed on a baby's shirt. All right, so here's part of the solution to your first programming assignment right there on the baby. Now let's talk a little bit about the process. So here's the program that produces Hello World. And in programming, we're going to talk about source code. And what source code is just a plain text file. All right, you could edit it in any kind of software package that can edit plain text. So you could use on Windows, you could use something like Notepad. If you're on a Linux system, VI. On a Mac, TextEdit. We'll talk more about Eclipse later. Dr. Java is another Java-specific development environment. Anything you can edit text with, you can make your source code. And it's human readable, and you can kind of see the structure here, and you can see the bit that prints out Hello World here. And it's stored in a file. And in Java, we're going to always use a .java extension to tell us that it's a Java source file. All right. This is the first step. First, you write this source code using whatever text editor strikes your fancy. All right. The next step in the process in Java is to compile that source code. All right. And when I use this notation %, this just means a command shell. And we'll learn more about the command shell, be it on Windows or on Linux or Mac OS, but I just use this little % as the shorthand. You're at this command shell, and there's Java C. Java C is the Java compiler that comes with the Java development kit. All right. When you do Java C, you give it the name of the source file, in this case, helloworld.java. What Java C will do is convert this source code, this text file, into Java bytecode. Java bytecode is an intermediate language. It isn't so human readable. I mean, it's possible to try and work out what's going on by looking at it. But what the bytecode is just a middle ground between the high-level language, which is Java, and the machine language. This Java bytecode isn't specific to a particular processor. It's just closer to sort of the operations that a processor might need to do. And in that way, this bytecode, all right, and it comes out in a .class file. So you start with a hello world.java, you run the compiler on it, and you get a hello world.class file. This bytecode file is what you can run on any system that has the Java virtual machine. So you could actually take this hello world.class file that maybe you compiled on Windows and move it over to a MacBook, and you'd still be able to run the same program without necessarily having the source code. So that's the first step in getting your Hello World program to work, but there's no Hello World being printed yet. All you did was convert this .java file into the bytecode in a .class file. All right. Given the .class file, the step you need to run it is another command. So at the command shell, and we'll look at, you can also do this using something like the Eclipse IDE. But if you're at a command shell and you type Java hello world, okay, and note just hello world without any extension, this is going to run that program. This is going to convert that intermediate bytecode into something the CPU understands and then actually executes the program. And here's a view of a DOS command shell where I've run my hello world program, and as you can see, it prints out hello world. We're going to use, or at least I'm going to recommend you use the Eclipse IDE in this course. And what an IDE is, it stands for an integrated development environment. All right, and it's a software package that just makes it easy for you to develop programs. And as you can see in this screenshot of the Eclipse IDE, you can see your source code here in the center. So here's our Hello World program. I put some little comments. That's what the / are. So I put my name and my username and a description of my program up there. And it helps manage the process of writing the source code. You can see it's colored things in different colors. It's put some things in italics. It's put some things in bold. All these different things help you understand your source code better. So it helps the programmer make fewer mistakes. You could do this in Notepad. You just would not have any of this syntax highlighting or coloring of your text. It also allows you just to hit the run button up here, and in a future video I'll show you how to install the Eclipse IDE, as well as how to get around and run Hello World using it. All right. It's not required. You can do all the programming assignments in the course without the Eclipse IDE, but I do recommend it. It makes your job easier. If you make mistakes, Eclipse will highlight your mistakes and give you usually pretty good advice on what went wrong. There's no cost. It's a free software package. You can just go download it. And as I said, syntax highlighting is a big help. This helps you spot mistakes. Okay, it flags likely mistakes, or it flags things it knows for sure are mistakes. All right, it's a very powerful software package. Professional Java programmers develop industrial strength software using Eclipse, and because it's such an industrial strength product, it has many features. We are going to ignore 95% of them. We're going to use a very small subset of them, and you can just safely ignore many of the options and menus in Eclipse. Installation, like I said, there'll be a another video showing you how to install Eclipse. There's also instructions on the course site giving you a step-by-step process for installing both the Java development kit and the Eclipse IDE. While you can do some stuff in Eclipse, other stuff is best done at the command line, and part of this course I'm going to teach you how to use the command line, how to compile programs on the command line, how to run programs at the command line, because it's an important skill for computer scientists to know. All right, Here's a view of programming from 10,000 feet. You've got your program, all right? And you could pretend your program is just a black box. All right, you don't know what's in there. You don't know what it does. But what its function is to take some input. You feed your black box, you feed your program an input string, for example, Alice, all right? And its whole job in life is to convert that to some output, like, for example, hi Alice, how are you? All right, it's taken this input and put it in here in the output, and that's the job of your black box. All right, you've got input and it produces output. Here is a basic Java program. All right, and we'll go through some of the anatomies. You could imagine, and we'll look at next time the actual code, its job, this cost calc program, is to take some input, namely the name of a fruit, a quantity of that fruit, and a price per unit of fruit, and calculate how much it costs to buy that many units of the fruit. All right, your input is bananas, 12 and 21 cents. So what are the different parts of the Java program? All right, first of all, we've got this public class and then a name. This is the name of a class, and everything in Java is going to exist in a class, and the name of the class, the thing after the public class, the cost calc, all right, it must match the name of the file. All right, whenever you have a class called cost calc, it must exist in a file costcalc.java. Okay, no fair calling this file something else. It's also case sensitive, so be careful. Make sure you have exactly the same capitalization in your class name as in your file name. Otherwise, things may not work so well. All right, that's the first part of the Java program. For now, we're going to put all the action inside of these two curly braces. All right, these curly braces, they always have an open curly and they have an end curly, and they denote a certain block of code. All right, everything in the public class cost calc is inside this set of curly braces. All right, inside this set of curly braces is where we're going to put our programs for the time being. We'll just put various bits of text in there to make our program do different things. Here is where the input comes in. String, square bracket, args. The input's going to come in via this thing called args, and we're going to talk more about exactly what this is and how you use it. But this is where the input comes, and then if you're doing any output, it's going to occur inside the action area here between the two curly braces. So let's talk a little more about that input array args. This specifies what's called an array. Args is the name of the array, and the array can contain 0 or more things. When you run this program on the command line, or when you run it from the Eclipse IDE, you can specify 0 or more input arguments. All right, I've run Java, so this is the command to run the class file. All right, the bytecode's in costcalc.class. I could give it nothing. All right, that was what I did for Hello World. But for cost calc, I know it takes some input. It takes the name of the fruit, the quantity of the fruit, and the price per unit. I give that by just putting spaces. So I run Java cost calc and I put spaces between all the command line arguments. That's how you get the input. And we'll look at arrays in detail in future lectures. But for now, in order to do your first programming assignment, you need to be able to get some input. You know, if you don't have input, your program is going to be pretty boring. Right? Your programs need to change depending on its input to make the programs very interesting. And if in your program you put the text args square bracket 0 end square bracket, what that refers to is whatever this first command line argument is, in this case bananas. If you put args square bracket 1, you're going to refer to the second thing, 12, and args bracket 2 is the 21 cents. All right, so anywhere in your program you see this, you can kind of just mentally substitute bananas for the time being, and args bracket 1 for 12, and so on. All right, and we'll look at data types in the next lecture, but it turns out when these things come in as input, regardless, I know 12 isn't, it's a number, and so is 0.21. But as far as Java is concerned, they're all just different strings. They're all just text for the time being. And we'll look in the next lecture how you get around that and how you convert things to different forms. The other important thing about this args variable is it has another property. If you do something args.length, what this does is tell you how many things are in it. All right, this args array may have nothing in it, or like if you didn't pass, like if you erased bananas 12 and 0.21, args.length would be 0. If I only included bananas, args.length would be 1. If I only include bananas and 12, it'd be args.length would be 2. All right, args.length provides you a way to know how much data was passed into your program. In the last slide, I showed you how you get command line options in using the command line. All right, but probably if you set up Eclipse, you're going to want to do it from Eclipse, and you can do that. And in another video, I'll walk you through this. But here's a screenshot of it. Before you run your program, you can go to this Run Configuration dialog box, and inside of there's an Argument tab. And in the Argument tab, just like before, I entered this on the command line. I enter the same thing just with spaces in this Argument tab, and then this will get passed in as the input to the program. All right, and here's the same thing in the command shell. So I'm running cost calc, and I'm passing in the 3 command line arguments. All right, so that's at a very high level where we're going here. You've got source code, all right, something in a .java file that you just write in some text editor, maybe Eclipse or Notepad or whatever. You compile it to this intermediate language, Java bytecode. Then you run the bytecode using the Java command, the Java JVM, and that actually executes your program and produces the output. I've shown you how to write your first program, Hello World, and we've discussed an important aspect of programs. All interesting programs take some variable input. They take something different every time, and they do something different depending on that input. And as a first input type, we're going to work with these arguments passed into the main function. So this args array. And for now, our output will be using this system.out.println. Anything you give to this command in Java is going to print out to that console window. And this allows us to do programs that produce text. And then in future lectures, we'll learn how to make programs that do output using other things like drawing and graphics and sound and so on.